Good morning to all. In today's class, we will discuss types of inheritance. Okay. Last class, I explained the definition of inheritance and I explained one program on single level inheritance. Okay. Now we will revise once. After that, we will complete multi-level inheritance. So already explained, Java supports only three types of inheritances. They are single level inheritance, multi-level inheritance and hierarchical inheritance. Okay, these are the only three different types of inheritances which are supported by Java. Okay, Java supports three types of inheritances. They are single level inheritance, multi-level inheritance and hierarchical inheritance. Okay, we will see one program on each type. Next, Java does not support multiple inheritance and hybrid inheritance. Okay, multiple inheritance means one class extends more than one class. It is not possible in Java, but it is possible in C++ language. So in Java, one class extends only one class. Okay, means here if you see this diagram, this is subclass and these two are superclasses. The syntax for this diagram is class A extends B and C or B comma C. Means here the subclass extends two superclasses. It is not possible in Java. This is called multiple inheritance. So Java does not support multiple inheritance and also hybrid inheritance, because hybrid inheritance is a combination of multiple inheritance and multi-level inheritance. Because Java is not supporting multiple inheritance, that's why Java also does not support hybrid inheritance. Okay, so Java does not support multiple inheritance and hybrid inheritance. But we can achieve multiple inheritance through interfaces in Java. When we discuss interfaces, I will explain how we can achieve multiple inheritance through interfaces. Okay, now remember, Java supports only three types of inheritances and Java does not support two types of inheritances. Totally here we have 5 types of inheritances actually. In C++ language, it supports all these 5 types of inheritances. But here Java supports only 3 and does not support the remaining 2 out of 5. Okay, now coming to single level inheritance program, already explained in the last class, we will revise once, only I will explain the concept in this program. So here we have, so what is single level inheritance means? There should be only one superclass and we can have any number of subclasses. Okay, so the structure for single level inheritance is, see, either this or this. Both are single level inheritances. Here one superclass and one subclass. This is single level inheritance, or one superclass and we can have any number of subclasses. This is also single level inheritance. You can write the programs on either this, using this diagram or using this diagram. Now last class I explained one program on single level inheritance. So here, if you take the gist of this program, here we have one superclass, class A. Okay, here there is no extents. First remember, it is class A, it is superclass, it consists of one instance variable and one method. Means class A consists of only one variable and one method. They are A and M1. Next, this I am taking only one subclass, that is class B extends A. When you use extends A means all the members of this superclass, that is A, are inherited to the class B. Means the members of B. So how do we know the members of B are? We can take the members of class A and its own members. Okay, that's why class B consists of two variables A and B and two methods, they are M1 and M2. See, class A consists of one variable and one method, but class B consists of two variables and two methods, Even though in class B we are writing only one variable and one method. This is the advantage of inheritance. Without writing this code in class B, we are using simply extends A. Means the entire code of class A is inherited to class B. That's why in class B we have the code of class A as well as its own code. So that is the advantage of inheritance. We use extends keyword to achieve inheritance. Okay. So class B consists of its own members as well as its superclass members. Here B is called subclass and A is called superclass. After that, in inheritance, we will create objects for subclasses. Okay. Here, how do we create objects for superclass and subclasses? Inside the class test, inside the main method, I will create objects for superclass and subclass. So using the superclass object, we can access only superclass members, that is A and M1. But if you create object for subclass, we can access the members of the superclass as well as subclass. That's why here with the subclass object I can access two variables A and B, and I can access two methods M1 and M2. Okay. So this is a program on single level inheritance. In inheritance, always try to create the object for the subclass, because subclass contains its superclass code as well as its own code. So if you create the subclass object, we can, through that subclass object, we can access both the members of the superclass and its own members. That's why subclass is important in inheritance. So here, how do we create subclass object is this B1 is equal to new B, like any class only. So this is the object creation for subclass. With this reference variable, I can access the members of class A and also class B. That is the advantage of this inheritance. So the advantage of inheritance is code reusability. Next, similarly, this is also a program on inheritance. Here, if you see, there is only one subclass, only one superclass, but here we have two subclasses. They are B and C, because B extends A and C also extends A. It is correct in Java, means it is a single level inheritance structure. So here we have only one superclass A and two subclasses B and C. Okay, it is correct. So how do we write the program? Here B can access the members of A and the class C can also access the members of A. So here we have two subclasses, they are B and C, and one superclass, that is A. So B can access the members of A, and also C also can access the members of A. Okay. How do we write the program? You can write the programs on your own once you understand the concept. No need to by heart the programs. So here class A is superclass. No. Here I have taken same one variable and one method. And class B extends A. In this class B, I am taking one more variable and one more method. But here inside class B, we have two variables A and B and two methods M1 and M2. Why? Because B extends A. Okay. Next, similarly, class C extends A. Means here C, inside C, again I am taking one variable and one method. And inside C, we have again two variables A and C and two methods M1 and M3. Because C also extends A. Means all the members of the class A are inherited to class C also. Here we can understand like this. All the members of class A are inherited to the class B and also inherited to the class C. So B is having its own code as well as A's code. Similarly, C is also having its own code as well as A's code. Okay. And now here, which one is better to create objects? So when if you create object for class B, we can access the members of class A as well as the members of class B. Like that, if you create object for C, again we can access the members of A as well as the members of C. That's why in this, okay, try to create the objects for B and C. Okay, no need to create the object for class A. Okay, in inheritance always create the objects for subclasses. If you create the object for superclass, there is no use. If you want to create, you can create. This is superclass object. With the superclass object, I can access only A and M1. But if I create subclass object, that is for B, I can access two variables A and B and two methods M1 and M2. Similarly, you create object for C, that is C1 is equal to new C. So with that C1 I can access the variables A and C and also M1 and M3. Okay. So with this close the main method and close the class. With this it is a second program on single level inheritance. Now the next concept is next. Now I will explain the inheritance concept with respect to constructors. Okay. Here what is the definition of inheritance? The process of getting variables and methods from one class into another class is called inheritance. So in single level inheritance, we have only one superclass and we can have any number of subclasses. Okay. Up to this already we know. Now I am introducing constructors in inheritance. Okay. Regarding constructors, what is the concept here in inheritance? See, constructors of superclass are not inherited to its subclasses. See, means as per the definition of inheritance. See, if you see the definition of inheritance, the process of getting variables and methods from one class into another class is called inheritance. No? Means from this definition we can understand that only variables and methods of the superclass are inherited to its subclass, but constructors of the superclass are not inherited to its subclass or classes. Okay, we can have any number of subclasses no, for the superclass. That's why here the important point to remember is here constructors of superclass are not inherited to its subclasses. This is very, very important. Only variables and methods of the superclass are inherited to its subclasses. Okay. Now we will write the programs on single level inheritance and multi-level inheritance by using constructors. You know how can we write the constructors? No, already explained constructors concept in depth. And now remember the point: constructors of the superclass are not inherited to its subclasses. Okay. Now I will write one program on single level inheritance with constructors. The previous two programs, if you observe the previous two programs, here we have not used constructors. See, if you take this program, this is class A. Here it consists of only one variable and method. In class B also, if you see, only one variable and one method. Means there is no constructor in class B and there is no constructor in class A. And if you observe the class C, it also does not contain any constructor, only variable and method. So the previous two programs are without constructors. We have written the programs on inheritance. Now we will write the inheritance programs using constructors. Okay. Now I will take the structure like this. Here I am taking one superclass. In that superclass I am taking one variable, one method and one constructor. You know how to write the constructor. The constructor name and class name must be same. Okay. So here inside the superclass I have one variable, one method and one constructor. Like that in subclass B I have one variable, one method and one constructor. Okay. So here this is constructor for class B. Okay. Suppose if you take the class B members. So class B extends A, no? Means all the members of the superclass are inherited to its subclass except constructors. You remember this one. Now add this point. So when you write class B extends A, what does it mean? All the members of the superclass are inherited to its subclasses except constructors. That's why we will see the members of the class B. So own members of class B are one variable, one method and one constructor. Next the inherited members are A, M1. If you see A, M1 method. But if you see this constructor, it is not inherited to class B. Okay. This is not there here. Only variables and methods of the superclass are inherited to its subclasses. not the constructors. Constructors of the superclass are not inherited to its subclasses. That's why if you see the members of the class B, we have the inherited members are A and M1, and own members are B, M2 and this constructor. Okay. Now we will see the program on this structure. Based on this structure only we will write the program. First, whenever you want to write the inheritance programs, first write the structure like this. In the superclass, which members you want to take and which constructors you want to write in that superclass. And in the same way, inside the subclass, first you write like this structure. After writing this structure, writing the program is very, very easy. Now we will see the program based on the structure. Now we will write class A. Okay. So inside the class A, I have one variable, one method and one constructor. Now I will write the class with these three. So here one variable is A and one method is M1 and one constructor. You know the constructor now. What is the main purpose of constructor in any class? The main purpose of constructor is to initialize the instance variables of that class. So here if you observe, there is only one instance variable for this class, that is A. So inside this constructor, I will initialize the instance variable. How I will initialize the instance variable inside the constructor is by using the parameterized constructor. Already I explained in depth about parameterized constructor. This is called parameterized constructor with one parameter. So how many parameters should we take inside the constructor is based on the number of instance variables of that class. Here we have only one instance variable. That's why we have to take only one parameter for this constructor. That's why here I have taken the same data type and same variable. When you take the same means parameter name which is same as the instance variable name, then inside this constructor use this. This refers to the current class object. That's why this dot A is equal to A. So inside the constructor we are initializing the instance variable of this class. That is the purpose of the constructor. So inside the superclass I have written one variable, one method and one parameterized constructor. That's it. Next, I will take subclass. So class B extends A. Okay. Now again in class B we will write first its own members. What are the own members of class B as per this structure? B, M2 and constructor. Okay. Now we will write the class B using those three. Now this is class B. Understand class B. This is subclass. This is superclass. So inside the subclass, first I will write the own code for class B. That is one variable int B and one method, that is M2. Here inside this method I will print it is B's method. Okay. Next here inside the class B I will write one constructor. Now how it is called parameterized constructor. So how many parameters should we take for this constructor is based on the number of instance variables of that class. Here if you see the class B, so what is the how many instance variables are there inside class B? Here this is one instance variable B and one more instance variable, that is A. This is inherited from class A to class B, no? That's why class B consists of two instance variables. They are A and B. That's why I want to initialize the two instance variables inside the class B using the parameterized constructor. That's why I will take two parameters, okay, inside this constructor. That's why are as parameters of this constructor. Here the number of instance variables are 2, that is A and B. That's why here I will take two parameters. They are with the same data type. That's why int A and int B. Here I am using the parameters name which are same as the instance variable names. That's why what I will do is I will use this. So this dot A is equal to A and this dot B is equal to B. I already explained this concept. So inside the class B, I have taken one instance variable, one method and one constructor. Okay. And what are the inherited members from class A? So inherited members are A and M1. This constructor is not inherited to class B. This is important. So constructors of the superclass are not inherited to its subclasses. Remember this point. Now after writing two classes, that is superclass and subclass, I will take one more class test. Inside that I will write the main method. Inside the main method I will create the objects for superclass and subclass. Actually there is no need of creating object for superclass. There is no use of this object. But for your understanding, initially try to write the objects for superclass also. Try to create the object or objects for superclass also. Here I am creating one object for superclass and one object for subclass. But here inside the superclass I have written one parameterized constructor. That's why how do we invoke that parameterized constructor is by sending this value to that constructor. Okay, we will see the constructor of this class A. So inside class A we have one constructor that is taking only one parameter. That's why we have to send one value to this parameter, that is to variable A. How do I send this? Already explained. Constructors are invoked at the time of object creation. Constructors need not be invoked separately like methods. So whenever you create objects, at that time only the constructors of that class are invoked automatically. So here this is the syntax for object creation for class A. At this time only we have to invoke the parameterized constructor of that class by giving this value. Okay. Now what is the statement? A1 is equal to new A of 10. So whenever when you execute this program, you will get what? First main method is invoked by JVM. After that it finds the first statement. This is the first statement. So when this statement is getting executed, first this constructor will be executed. Okay, whenever we create an object, at that time compulsory one constructor must be invoked, whether it is default constructor or user defined constructor. And now this is the constructor. So from this statement it will go to the constructor of class A. So this is the matching constructor for that A of 10. Now 10 is assigned to this variable A. After that one object is created for class A. Inside only the instance variable of that class is stored and assigned with 10 using this dot A is equal to A. Okay, this refers to the current class object. Now our current class object is this one. This is the current class object. Now here with this statement, inside the memory one object is created. Okay, the inside that only instance variable of that class is stored, that is A is stored, and the A is assigned the value 10. And the address of this object is stored in the variable A1. Means inside the memory one object is created for class A and that object consists of only one instance variable A and the value is assigned with 10 using the parameterized constructor of class A. In the same way, now I am creating the object for subclass. So how do I create the object for subclass is, again I am invoking the parameterized constructor while creating the object for subclass. So from this statement, actually it is B. Correct this as B. So B1 is equal to new B of 20, 30. So from this, okay, it will go to the parameterized constructor. So what is the matching parameterized constructor inside class B is, this is the matching one. That's why JVM will execute this constructor. So after executing that constructor, okay, inside the memory one object is created for class B, okay, and the address of the object is assigned to the variable B1, and inside that object, that is the object for class B now. So inside that object two instance variables are stored and the values for these two instance variables A and B are 20 and 30. Okay, so using the parameterized constructor of class B, we are initializing the instance variables A and B inside the object. So here this is superclass object with inside that object only one instance variable A with value 10. Here this is the subclass object, that is B's object. Inside that two instance variables are there, A and B, with the values 20 and 30. Now we have two objects, that is first one is superclass object and second one is subclass object. So with the superclass reference variable, we can access the members of the superclass, and with the subclass reference variable, we can access both the members of the superclass and subclass. Okay, that is the advantage of this subclass object. Now, if you take the reference variable for superclass, we can access the variable A and the method M1. Similarly, if you use the subclass reference variable, with this I can access both the variables A and B and both the methods M1 and M2. Okay. So here in this program, you can understand the constructors concept. Here the important thing to remember is constructors of the superclass. This is the constructor of the superclass, that is class A. So this constructor is not inherited to its subclass. See, here you can't find that constructor of class A. Only we can find instance variable A and method M1. Only variable and method, these two are inherited from class A to class B. Okay, constructor of the superclass is not inherited. Okay, this is a program on single level inheritance with constructors. Okay, now we will see one program on multi-level inheritance. Here also we will use constructors. So here I am taking three classes. You know multi-level inheritance. First one is A. Okay, A is the superclass. I will show you the diagram. With respect to that diagram, we will write the program. What is multi-level inheritance diagram? Types of inheritance. Actually, in each program we have to draw the first diagram, then write. This is the, for this I am writing that program. This is multi-level inheritance. Here I have first subclass A, then subclass B, then subclass C. Here B extends A, then next C extends B. So what is the advantage of this multi-level inheritance is B contains the code of A and its own code. Similarly, C contains its own code as well as A's code, B's code and also A's code. So in this diagram, if you create the object for C, so using the C's class object, we can access the members of both the classes B and A and also its own members. So in this diagram, always try to create the object for the last class. So in multi-level inheritance, always create the object for the last class. Because if you create the object for class C, we can access the members of its superclasses, that is both B and A, and also its own members. That is the advantage of creating object for C. Okay. For this diagram, I am writing the program. Once you understand the concept of multi-level inheritance, writing the program is very, very easy. You can write on your own. See, in Java, no need to by heart the programs. Whenever you write the inheritance programs, first draw the structure, accordingly write the program. Okay. Now I am writing a program on multi-level inheritance now. That's why you use that same diagram. There we have three classes, A, B and C. Okay. So in A, when you want to write the multi-inheritance programs, okay, we can take constructors are not required. No need to take constructors also. But try to understand the constructors concept in inheritance. That's why try to take the constructors also inside each class when you write the inheritance programs. Okay. In addition to variables and methods. Now here the structure is like this. If this is superclass, here I am taking one variable, one method and one constructor. Okay. Next inside class B, again I am taking one variable, one method and one constructor. Inside class C also I am using one variable, one method and one constructor. Okay. For this structure, I will write the program. I will take three classes. We will see how to write the classes. Okay. First class A. Okay. And now I am here taking one variable, one method and one constructor. Now you know how to write the constructor. So always how to write the constructor is the number of parameters in the constructor is equal to the number of instance variables of that class. Here this class consists of only one instance variable. That's why take only one parameter. That's why this syntax is called parameterized constructor with one parameter. Okay, so this code is same as the previous program code. One variable and one method. Inside this method, what we are printing, this is A's method. That's it. Okay, and through this constructor, we are initializing the instance variable of that class. Okay, this code is same as the previous program. Now we will see. I think B's code also same. Class B extends A. So through this extends A, okay. Now the variable of A and this method of A, these two up to this, only this code, this part is inherited to its subclass. It is not inherited to its subclass. That's why subclass consists of two variables A and B and two methods M1 and M2 and also its own constructor. So inside class B I have written one parameterized constructor to initialize the two instance variables of this class B. In class B we know that we have two instance variables, they are A and B. That's why to initialize the two instance variables of class B, I will use this constructor. So this syntax is parameterized constructor with two parameters, and the purpose of this constructor is to initialize the instance variables of that class. Okay, so this class is also same as the previous program. Okay, now I am taking one more class. So class C extends, here class is not there, strike off this one. So class C extends B. What does it mean? Now class C contains all the members of class A and class B. That is the advantage of multi-level inheritance. So all the members of all, not all, this only variables and methods of class A means this part, and also the variables and methods of class B, this part, okay, are inherited to class C. Now what we can understand? So class C consists of three instance variables. They are A, B and C. Means class C contains the code of class A and class B. That's why class C consists of three instance variables. They are A, B, C and three methods. They are M1, M2 and M3. Okay? Because the entire code of both the classes A and B is inherited to this class C. So that is the advantage of multi-level inheritance over single-level inheritance. Here this subclass consists of the code of both superclasses A and B and its own code. That's why class C consists of, here focus on class C. This is important class in this multi-level inheritance. So class C contains the code of class A and also class B. Okay, and its own code. Now we will see the own code. So here also, here in class C, it is having its own instance variable C and own method M3 and constructor. See how to take the constructor inside class C is, we know inside class C we have three instance variables. They are A, B, C. So how do we write the parameterized constructor is the number of parameters. Okay, the number of parameters is equal to the number of instance variables. We know this class consists of three instance variables A, B and C. That's why here we have to take three parameters for this constructor. The constructor name and class name must be same, and constructors do not have return type. If you observe, there is no return type for this, and the constructor name and class name must be same, and it is called parameterized constructors, and the number of parameters for this constructor is equal to the number of instance variables of this class C. That's why here I have taken three parameters. Okay, and here I am using the same names. Here the instance variable names are A, B, C, and here the parameter names are also A, B, C. When you use the same names, then you have to use this. That's why this dot A is equal to A, this dot B is equal to B, this dot C is equal to C. This is the initialization of instance variables of class C. Okay. So now class C is completed. Now we have written three classes A, B, C. After that, always create the object for class C, because through class C object we can access the members of three classes, class A, class B and also class C. But for your understanding, initially try to create objects for all the three classes. This is class A object. Inside class A, we have one parameterized constructor. Okay, through that constructor, I am initializing the object. Okay, of class A. Next, similarly, this is the object for class B. This is the object for class C. So here inside the memory, so whenever this statement is executed, this will invoke the constructor of class A, which will initialize the instance variable A with 10. So here one object is created with A1. A1 points to that object. Inside that A is assigned 10. Similarly, here B's object is created with name B1. B1 points to the B's class object. Inside that the instance variables A and B are assigned with 20 and 30. So from this it will go to the class B and it will execute the matching constructor. Okay. So what is the role of constructor is to initialize the instance variables of the object. Okay. Similarly, whenever this statement is getting executed, from this the JVM will go to the class C and it will identify the matching constructor and it will execute that constructor. So through that constructor, I am initializing the instance variables of class C. They are A, B, C. So inside class C object, we have A is assigned 40, B is assigned 50 and C is assigned 60. And the object address is assigned to this variable C1. So inside the memory, we have three objects, one for A, one for B and one for C. Now with these reference variables, we will see what are the members which are accessed. And now with this reference variable, this is purely superclass object now. Means with this I can access only superclass members. That's why A1.A, A1.M1. Because superclass A consists of only one variable and one method. That's why with this reference variable I can access A and M1. That's it. Next, when you take the class object B, B extends A now. That's why through this reference variable we can access the members of both A and B. That's why B1.A and B1.B. Two variables I can access, two methods I can access. Next, this is important. Through C's class object, that is with this reference variable, I can access both the superclass members. Both means we can access the members of class B and also the members of class A. That's why C class consists of three instance variables and three methods. So I will access with this reference variable. Okay, this is C's object. And now here I will with C1 I can access three variables ABC and also three methods M1, M2, M3. If you observe, A and M1 are class A's members and B and M2 are class B's members and C and M3 are C's class members. So with the class or through this object I can access all the three classes members. That is the advantage of this multi-level inheritance. So with the object or by creating the object for class C, we can access three instance variables A, B, C and also three methods M1, M2, M3. So this part is very, very important in here. So if you execute that program, you will get this output. Okay, with this multi-level inheritance is completed. Next, we will see constructor chaining in inheritance. This is also important for exam point of view. So explain constructor chaining in inheritance. Okay. This is very, very important. Listen carefully. Now we know how to write the constructors in classes in inheritance program. Okay. Now we will see constructor chaining in inheritance. So with respect to multi-level inheritance, I will explain this concept, that is constructor chaining. So to explain the concept of this constructor chaining, use multi-level inheritance. Or with single level inheritance also I can explain, but this concept is available only in inheritance programs. Okay, we can use single level inheritance or multi-level inheritance for explaining the concept of constructor chaining. Okay, here we will see. Here I think we have taken multi-level inheritance. You can take single level inheritance also to explain the same concept. that is take only up to this A and B, one superclass and one subclass. But here I am explaining the constructor chaining concept with multi-level inheritance. That's why I have taken 3 classes, A, B, C. Already explained multi-level inheritance program now with constructors. Okay, now I will explain this one. So this is the structure I am using. Okay, now first I have to write class A, then write class B, then write class C. Okay, inside class A I can use variables, methods and constructors. In the same way, inside class B I can use variables, methods and constructors. Inside class A also I can use variables, methods and constructors. Concentrate on constructors. Constructors are also behaving like methods only. Already explained the difference between constructors and methods. Okay. Now here I will use this structure to explain this concept. Now first I will take class A. So inside class A, here what I have written? I have written only constructor. So class A may contain variables, methods and constructors. No, it is not necessary to write variables and methods, not compulsory. Okay, so inside class A I have taken only one constructor. So what is this constructor? You know, no, this is user defined no-arg constructor. So the constructor name and class name must be same, and here no arguments. That's why we can say it is user defined no-arg constructor. User defined no-arg constructor. So what is the inside the user defined no-arg constructor? Here I have written system.out.println A's constructor. Means we are saying this is the constructor for class A using this printf statement. Okay. So the printf statement in Java is system.out.println S capital, system.out.println, inside the double quotes whatever you write that will be printed on the console. Okay, in Java we use system.out.println to in place of printf statement in C language. Okay, now here understand, class A consists of only one constructor, that is user defined no-arg constructor. Okay, I have written only one constructor for class A. Next, if you take the same diagram, here class B extends A. Now here class B extends A. So inside class B also I have written only one constructor. It is also user defined no-arg constructor. So inside that constructor what I have written? System.out.println B's constructor. Means we are saying this constructor belongs to class B. It is only for our understanding I have written like this. B's constructor. This is class B. In the same way, in multi-level inheritance, class C extends B. If you see this diagram, class B extends A, then class C extends B. Okay. Now inside class C, I have written again only one constructor, that is user defined no-arg constructor. Inside that I have written system.out.println C's constructor in double quotes. This is our program. Okay. So in class A I have written one constructor, and in class B also I have written one constructor, and again in class C also I have written one constructor. Okay. After that what I will do is, I'll already explain, no? In multi-level inheritance always try to create the object for the last level class. If you create the object for class C, we can access the members of class B, class A and also class C. That is the advantage of creating object for the last level class, that is for class C. So in this program, I will create object for class C only. If you want to create objects for class A and B also, we can create. Okay, no problem. But always better to create object for the last level class in multi-level inheritance. Okay. Now here I have taken one more class test. Inside that I have written main method. Inside that method I have created object for class C. So what is this object? How do we create? C1 is equal to new C. So from whenever you execute this program with Java test, then always JVM will invoke the execution, or will invoke the main method first. Always execution starts from the main method only. Okay, so this method is invoked by JVM with the statement Java test. Okay, now what is the first statement inside main method? C1 is equal to new C. So from this, okay, from this is the constructor for C's class now. Always whenever the object, whenever the statement is getting executed, the constructor of that class is executed now. So here this is the constructor for class C. So from this it will go to the class C and it will search for the matching constructor. This is class C. Inside class C, this is the matching constructor for this C. C of no arg. No? Here also what is the matching constructor in inside class C? C of no arg. What is the statement here? We have system.out.println C's constructor. So what is the output for this program? When you execute this program, already explained, no? Constructors of the superclass are not inherited to its subclasses. Means this constructor of class A is not inherited to class B. Similarly, the constructors of class A and class B are not inherited to class C. So constructors of the superclass are not inherited to its subclasses. Means in C we have only one constructor, that is this C. In B also we have only one constructor, that is B. In A also we have only one constructor. Even though we are writing class B extends A, the constructor of the superclass is not inherited to its subclass. Because of that, class B consists of only one constructor. Again, here we are writing C extends B, class C extends B. Means B's constructor and A's constructor, these two constructors are not inherited to the class C. Means class C consists of only one constructor, that is its own constructor. You understand this point? After that, suppose if you execute this program, this statement is executed. No? This is the only one statement we have written inside the main method. When JVM invokes this main method, it finds this is the only one statement. So when it executes this statement, from this it will go to the C's class, and this is the matching constructor for this one. See, these two are matched. So this is the matching constructor for this one, and this code is executed. What is there inside the C's constructor is system.out.println C's constructor. Now what is your output? I think you will say the output is C's constructor, because from this state, this is the class C's class object. No, from this statement it will go to this matching constructor and it will be executed. Means your output will be C's constructor, but it is not correct. Okay, here I will explain the output. Here the output is first, we will see the output. Here you will get the output is A's constructor, B's constructor and C's constructor. This is my output, but your output will be only C's constructor, because you don't know the in-depth concepts in inheritance, no, or constructor chaining, no. That's why your output will be only C's constructor, but my output is A's constructor, B's constructor and C's constructor. So how do we get this output? Now I will explain here we will get the concept of constructor chaining. Okay. Now here the concept is that inside each constructor, see, already explained while explaining the constructor rules. So one of the rules of writing the constructors or for constructors is inside each constructor, the first statement can be either super or this. These are no arg, remember. Okay. So the first statement inside each constructor must be either super or this, but default one is super. If you won't write anything inside the constructor, okay, then the compiler will add super of no arg as the first statement in the constructor. Okay, so this is added by the compiler for each constructor. This is the default one. If you want to write this, you have to write explicitly. But either super or this must be the first statement, remember. So this is the either super. If you want to write super also, you can write explicitly, no problem. If you won't write super inside the constructor, then compiler will add this one inside each constructor as the first statement. This is important. If you want to write this, you have to write explicitly. Okay, both are super of no arg or this of no arg, but if you want to write, you have to write explicitly as the first statement inside each constructor. But if you won't write anything, either super or this inside the constructor, the compiler will add super of no arg as the first statement inside each constructor. First we will see that statement. Here in class A, I have written one constructor now. This is A, no? So inside this constructor, the first statement is super, no? See, this is the second statement now. Even though we have written only one statement for this constructor, but compiler will add this statement, no? If you won't write either super or this as the first statement inside the constructor, the compiler will add by default super of no arg. That's why this is added by the compiler to this constructor. See, here this concept is applicable for user defined no arg constructor or user defined parameterized constructor also. For parameterized constructors also, the default statement is super of no arg, which is the first statement, whether it is no arg or parameterized constructor. Okay, now this is added by the compiler. In the same way, inside the class B, we have written one constructor. Inside that, we have not written either super or this. That's why compiler will add super of no arg, okay, as the first statement. Next, if you see C also inside each constructor, no. So inside this constructor also, we have not written either super or this. That's why the compiler will add super of no arg as the first statement inside this constructor. So based on that statement, here we have, in this constructor we have super, in this also we have super, and in C class constructor also we have super. Now we will see the flow. Now here I will explain one more point. Already explained in the first class. Every class in Java extends object class. This is by default. Okay. Well, already explained the default package in Java for any Java program is java.lang import java.lang.star. That is the default package. If you won't write also, compiler will add. And one more is what is the default super class? Okay. In Java, every class extends object class. That's why class A extends object. This is added by the compiler if you won't write. If you write also correct. Okay. Now extends object is there for class A. Now here you may get one doubt. That is class B extends A, no? Here already explained every class in Java extends object, no? But here if you write class B extends A, comma object, means it is multiple inheritance, no? Class B extends A, comma object, means it comes under multiple inheritance. Java does not support multiple inheritance. But here class B, even though we are not writing class B extends A, comma object through this multi-level inheritance. Okay, see what here on the top of this class A, we have object. Write with dotted lines, put arrow, upward arrow, and write object. Means on the top of this class A, we have object class. Only for this class, I will write class A extends object. Means all the members of the object class are inherited to class A. Next, if you take class B extends A. But inside class A, we have the members of class A and also class B, class object, no? That's like that. Class B also consists of all the members of object class and class A. Similarly, if you see class C consists of the members of class B, class A and also object. Okay, on the top of A we have object. That's why for classes B and C, no need to write class B extends A, comma object and class C extends B, comma object. If you write like that, it is multiple inheritance. We know that Java does not support multiple inheritance. Okay, but without writing class B extends A, comma object also, class A extends object. If you write like this, what will happen? All the members of the object class are inherited to class A. Then you write class B extends A. What does it mean? All the members of the class object and class A are inherited to class B. Means in class B also we can access the members of class object. Similarly, in class C also we can access the members of class object. Means object class members are available for classes B and also C. Without writing B comma object and here A comma object. Don't write like that. Because of multi-level inheritance. Here on the top of A we have object no. So all the object class members are inherited to A. Through A, okay, the class B consists of all the members of A and also object. Again through B, the class C consists of all the members of class B, class A and also object class. Like that, object class members are available for all the three classes A, B, C. Okay. Now we will see the flow. Now first I will explain the object class. Object class is very, very important. In object class they have kept important methods and important methods. Let us take like that. So here this is predefined class which is provided by the Sun developers. That is class object. Okay, capital O. Class object. Inside the class object, first I will explain only constructor. Okay, in one class I explained two methods, two hash code and two string methods. Both are there in the object class. I will explain those two methods later. First try to understand the constructor of object class. So here this is the constructor of object class, that is object capital O, norg, and it is open brace and closing brace, means null implementation. Inside the object class constructor nothing is there, means null implementation. Okay, you remember this one. Now we will see the flow. Now I will explain the constructor training. Again we will come from here. C1 is equal to new C. Okay, this is the first statement inside the main method. That's why this is the statement which is executed by JVM. So when JVM executes this statement, from this statement it will go to the C's constructor. This is the matching constructor. Okay, this will be executed. Now what is there in the first statement? Inside C's constructor, super of norg. From this it will go to the super class constructor. Means super class norg constructor. So what is the super class for C? B is the super class for C. That's why when JVM executes this statement, from this it will go to the B's constructor. Means this is the super class norg constructor. Again here the first statement is super of norg. Again from this, what is the super class for B? A. That's why from this statement again it will go to the super class. This is the super class now. That's why it will go to this constructor. Again inside this the first statement is super. Again what is the super class of class A? Object is the super class of class A. So from this statement it will go to the object class constructor. Means from this statement it will go to the object class constructor, means this is the matching constructor norg. This is norg now. That's why it will find the norg. So this is the object class constructor. First it will be executed. But inside the object class constructor nothing is there, means null implementation. But simply this is executed and again it will come back to the same statement. After executing this statement, this is the statement which is to be executed. That is what A's constructor. That's why here the output is first A's constructor. Again, so after printing this A's constructor, this A's constructor is completed now. After that, from this it will come to the same statement super. It will come back to the same statement super. After this statement we have B statement which is to be executed, that is B's constructor. That's why in the output A's constructor followed by B's constructor. Next, after completion of this B's constructor, again it comes back to the same statement, that is super, means this is completed. Next, after that we have C's constructor. So that's why the output is C's constructor. So after that this constructor is completed and class C also completed. Means the output is A's constructor, B's constructor and C's constructor. If you observe this program, it is a program on constructor chaining. Why? Because so here from C's constructor we are going to B's constructor. Next, from B's constructor we are going to A's constructor. Next, from A's constructor, we are going to object class constructor. Okay, that's why it is a program on constructor chaining. Through this constructor chaining, we are getting the output as A's constructor, B's constructor, and C's constructor. Otherwise, the output will be only C's constructor. Okay, if you don't understand the concept of constructor chaining, what will be your output is only C's constructor. These constructors will not be executed if you don't understand the concept of constructor chaining. So through constructor chaining, what we are doing is, from C's constructor we are going to B's constructor, again from B's constructor we are going to A's constructor, and from A's constructor we are going to object class constructor. Again, after completion of this object class constructor, we are coming back to the same statement, and the followed by statement is executed, means this constructor is completed. Again, we will come back to the same statement. Like that, this we will get the constructor chaining. So finally, you will get the output as A's constructor, B's constructor, and C's constructor. So this program is very, very important to understand the constructor chaining. So with this types of inheritance we have completed. If you want to write the program on hybrid inheritance, you draw your own structure, take multi-level inheritance and single level inheritance combination, and you try to draw one structure. Based on that structure, you take the variables and methods on your own in each class. Okay, you try to create the objects for the last level in hierarchical inheritance also. Okay, so with this types of inheritance programs we have completed. Next class we will see method overriding. It is very, very important in inheritance.